contributors in the field of science, 100 BC to 200 BC. Hipparchus, 190 BC, 120 BC. Hipparchus, a Greek astronomer, geographer, and mathematician, is often referred to as the founder of trigonometry. His work laid the foundation for understanding celestial movements and mapping the stars. Hipparchus compiled one of the first comprehensive star catalogues and introduced the concept of stellar magnitudes to measure the brightness of stars. His observations of the precession of the equinoxes were groundbreaking, revealing subtle shifts in Earth's axis over time. Hipparchus also made significant contributions to geography by improving the system of latitude and longitude for map-making. His mathematical ingenuity extended to refining earlier methods for calculating eclipses and planetary motions, enhancing the predictive accuracy of astronomical events. One of his most remarkable achievements was his development of a trigonometric table, which became a crucial tool for future astronomers. He also discovered and measured the distance between Earth and the Moon with impressive accuracy using geometric methods. Hipparchus's insistence on systematic observation and data collection set a new standard for scientific inquiry. His influence endured through the works of later astronomers like Ptolemy, who heavily relied on Hipparchus's findings in his own monumental treatises. Personal details about Hipparchus remain sparse, but he is believed to have conducted much of his work on the island of Rhodes. His dedication to meticulous observation and mathematical precision underscores his profound influence on both ancient and modern scientific practices. Hipparchus's commitment to integrating theoretical knowledge with empirical data exemplifies the essence of scientific methodology, making him a pivotal figure in the history of science. His contributions were integral in shaping the scientific revolution centuries later and influencing the study of astronomy in both the ancient and modern worlds. Archimedes, circa 287 BC, circa 212 BC. Archimedes, a Greek mathematician, physicist, and inventor, made profound contributions to multiple scientific fields. Famous for his principle of buoyancy, Archimedes' work on fluid mechanics has influenced engineering and design for centuries. He also developed innovative war machines and devices to defend his native Syracuse against Roman sieges, showcasing his mastery of applied science. Archimedes' mathematical achievements include the approximation of pi and foundational work in calculus concepts. His ingenious devices, such as the Archimedean screw for raising water, revolutionized practical engineering. Archimedes' studies in levers and pulleys established fundamental principles of mechanics that remain relevant today. His writings, including On the Sphere and Cylinder and On Floating Bodies, demonstrate an unparalleled ability to combine theoretical rigor with real-world applications. Archimedes was a polymath who also studied optics and geometry, and his discoveries influenced fields ranging from mechanics to astronomy. His personal life is woven with tales of intellectual curiosity and relentless problem-solving. His famous exclamation, "Eureka!" reportedly occurred during his discovery of buoyancy while bathing. Despite his untimely death during the Roman conquest of Syracuse, Archimedes' legacy endures as a testament to the power of human ingenuity and scientific exploration. His work on the measurement of geometric shapes laid the groundwork for modern calculus, and his practical inventions were precursors to later engineering advancements. Archimedes' approach to science was deeply rooted in observation and experimentation, elevating the role of empirical evidence in scientific inquiry. Eratosthenes, 276 BC, 194 BC. Eratosthenes, a Greek mathematician, geographer, and astronomer, is celebrated for his accurate calculation of Earth's circumference. Using simple geometric principles and observational data from different locations, Eratosthenes demonstrated the immense potential of empirical science. As the chief librarian of the Library of Alexandria, he had access to vast knowledge, which he synthesized to advance numerous scientific fields. Eratosthenes introduced the concept of latitude and longitude, revolutionizing cartography. His work in astronomy included studies on the size and distance of the Sun and Moon. He also devised the sieve of Eratosthenes, an algorithm for identifying prime numbers that remains a cornerstone in number theory. Eratosthenes' interdisciplinary approach made him a pioneer in creating connections between various scientific domains. In addition to his contributions to geography and astronomy, Eratosthenes made strides in the study of calendars and the Earth's tilt. His innovative thinking laid the groundwork for future developments in geodesy and the understanding of Earth's physical properties. Eratosthenes' personal life reflects his deep intellectual curiosity and commitment to expanding human understanding. Despite being nicknamed Beta, indicating a second-best status compared to other scholars, his achievements highlight the breadth and depth of his contributions. His innovative thinking and dedication to empirical research ensured his place among the most influential scientists of antiquity, and his methods of scientific inquiry continue to influence modern practices in science and mathematics. Seleucus of Seleucia, circa 190 BC, circa 150 BC. Seleucus, a Hellenistic astronomer and mathematician from Mesopotamia, was a strong advocate for the heliocentric theory originally proposed by Aristarchus of Samos. He was among the first to provide mathematical arguments supporting the idea that Earth orbits the Sun. Seleucus's work in tidal theory linked the phenomenon of tides to the gravitational influence of the Moon, showcasing his understanding of celestial mechanics. Seleucus's contributions to astronomy included refining astronomical tables and advancing knowledge of planetary motion. His integration of mathematics with observational data exemplified a scientific methodology that influenced later astronomers. His support for the heliocentric model demonstrated a forward-thinking approach that challenged prevailing geocentric views. Despite the limited documentation of Seleucus's life, his work was revolutionary for its time. His efforts helped form the intellectual foundation for later astronomical discoveries, and he is considered one of the early thinkers to challenge the geocentric model of the universe. He used mathematical methods to improve upon existing models and laid the groundwork for future breakthroughs in celestial mechanics. Seleucus was also instrumental in introducing new ways of calculating the positions of stars and planets, contributing to the refinement of observational astronomy. His insights into the nature of celestial bodies paved the way for later astronomers to build upon his ideas, particularly in the development of the heliocentric theory. Ctesibius, circa 285 BC, circa 222 BC. Ctesibius, a Greek inventor and engineer, is often regarded as the father of pneumatics. His pioneering work in using air pressure and vacuum principles led to the development of innovative devices, including the water clock and the hydraulis, a type of pipe organ. Ctesibius's contributions to engineering showcased a deep understanding of mechanics and fluid dynamics. His inventions were not only practical but also reflected an artistic flair. His water clocks, for example, incorporated aesthetic designs and were used to measure time accurately in public spaces. His treatises on pneumatics laid the foundation for future studies in fluid mechanics and engineering. Despite the loss of his original writings, later works by Hero of Alexandria preserved many of his ideas. Ctesibius also explored the use of compressed air to power mechanical devices, advancing early studies of energy and force. His work influenced the development of later technologies, including those used in the modern era. Ctesibius's personal life is largely obscured by history, but his creative genius and contributions to practical science highlight his role as a key figure in ancient engineering. His ability to blend functionality with artistry set a standard for innovation that continues to inspire. Ctesibius's legacy is evident in the continued use of pneumatic technologies and mechanical systems, which are foundational to modern engineering and technology. Apollonius of Perga, circa 262 BC, circa 190 BC. Apollonius, a Greek mathematician known as the Great Geometer, made significant contributions to the field of geometry. His work on conic sections laid the groundwork for later developments in astronomy and physics. Apollonius's treatise, Conics, introduced terms such as parabola, ellipse, and hyperbola, which remain fundamental in mathematical language. Apollonius's mathematical rigor extended to solving complex problems involving curves and surfaces. His methods influenced the study of planetary orbits and were later employed by astronomers like Kepler and Newton. His work also included contributions to the development of coordinate geometry, bridging the gap between algebra and geometry. Apollonius's personal life is not well documented, but his intellectual legacy reflects a deep passion for mathematics and its applications. His systematic approach to problem-solving and innovative thinking cemented his status as one of antiquity's greatest mathematicians. Apollonius's influence on both theoretical and applied sciences underscores the enduring relevance of his contributions. His study of conics has influenced not only mathematics, but also physics and engineering, laying the groundwork for later technological innovations. Apollonius also contributed to the understanding of the geometry of light and optics, showing how mathematics can describe the properties of natural phenomena. If you found this video interesting, don't forget to like, share, and subscribe for more. Stay tuned for the next chapter in our series on revolutions and progress that shaped our world.